Welcome back all. So let's continue with the remaining topics here. Just in a previous session, we had discussed what B tree is. So B tree is nothing but a specialized M-way search tree where we have additional constraints on minimum number of pointers and values. Now with B tree understanding, if we move on to the B plus tree, then it is much similar to B tree with few minor differences. Okay. The first one is all the leaf nodes are connected to each other in a linked list manner. So these are the leaf nodes. Okay. These are the leaf nodes, and leaf nodes are connected to each other in a linked list manner. So the orange links that you are looking at here is the additional part here. So in a B tree, we were having null value at this pointer, at this pointers, right? But just first and last pointer of a node will not be null now, but it will be pointing to the right side or left side next or the previous node in a linked list manner. So this will not be null. First and last pointer will not be null in a node. Internal will be null. Right? So like this way, the first change here in B plus tree is all the leaf nodes are connected to each other in a linked list manner. That's one change. And the second change, data will always be in a leaf node. So leaf node को जब आप split करोगे, now in B tree what we were doing was, B ट्री के अंदर हम जब नोड को स्प्लिट करते थे तो मीडियन वैल्यू को ऊपर भेज देते थे पेरेंट नोड में. नाउ बीइंग अ डेटा, वो वैल्यू एक्चुअली अगर वो डेटा है तो B प्लस ट्री में आप क्या करोगे, वो वैल्यू को आप लीफ नोड में ही रखोगे लेकिन उसकी कॉपी जनरेट करके पेरेंट नोड में भेजोगे. सो व्हाट इट मीन्स इज इन अ B प्लस ट्री, internal nodes will have keys and the leaf nodes will have data, key and data. And that's the reason actually B plus tree is majorly used in indexing. Okay, when you create an index for your data, then the leaf node will contain your data always, and all the internal nodes will have keys. So index keys वहाँ पे रहेंगी. That means if we split our node here in B plus tree, then we will generate a new key and propagate it to the parent node. So these are the two changes. First change, leaf nodes are connected in a linked list manner. So आपका data जो है वो continuous manner में रहेगा. And the second change, internal nodes will have keys, leaf nodes will have data. So that's the other change from B to B plus. So if we go and have a look at the insert operation on B plus tree, then it is similar to the B tree. Okay, insert at a bottom level. अब अगर leaf node overflow होता है, which means maximum constraint से ज़्यादा value हो गई. If leaf node overflows, then हम उसको split तो करेंगे. Split that page. अब यहाँ पे node की जगह पे उसको page बोला because it is a data here. So you split that page and copy the middle element as a index page. उसके parent में आपको middle value जो है उसकी copy generate करके parent node में भेज दो. Now parent क्या होगा? Internal node. Internal node will have keys, तो हम उसको index page बोलेंगे. So all the internal nodes are actually index pages, and the leaf nodes are the data pages. Fine. Now अब अगर आप new key generate करके parent node में भेजते हो, which is the index page, if index page overflows तो repeatedly वो भी split होगा, लेकिन जब आप इंडेक्स पेज को स्प्लिट करते हो तो की कॉपी करने की जरूरत नहीं है, वहां पे की डायरेक्टली मूव हो जाएगी पेरेंट नोड में। सो अगर डेटा स्प्लिट होता है तो नई की जनरेट होगी, अगर इंडेक्स स्प्लिट होता है तो नई की जनरेट नहीं करनी है, डायरेक्ट मूव कर दो मिडिल वैल्यू को। सो इतना याद रखो, लीफ नोड को स्प्लिट किया, देन कॉपी द वैल्यू, इंटरनल नोड को स्प्लिट किया, देन सिंपली मूव द वैल्यू. So that's what you should remember when you are working with B plus tree. Other than that, everything will be similar to B tree. Now let's take one example here. Let's say we go for order 4. Now here, remember, if M is equals to 4, then maximum pointers will be 4 and values will be 3. And minimum, now always we go for M by 2 ceiling part. So 4 by 2 is 2 and minus 1, so 1. Which means minimum 2 pointers, 1 value, and maximum 4 pointers, 3 values should be there. Now with that side note, let us create our B plus tree here. If I go and insert 1, 5, and 8, these 3 values, then I don't have any problem because I'll be having maximum 3 values and 4 pointers in a single node. Now this will be my data node. So that's okay. Next, let's say we insert 10 here. Okay, what we do is we insert 10 here. Now when I insert 10, then 1, 5, 8 and 10, there will be 4 values and 5 pointers, which is not possible. We need to split this data node. अगर मैं इसको split करता हूं तो middle value से split करूंगा. Now when we have 4 values, it's not possible to have exact middle value, so you can take either 5 or 8. Now let's say we've decided we are going to take 5, and this 5 is gonna be at a left side. So हम क्या करेंगे, we will divide this node, we will split this node in 2 sub nodes, 8 and 10 here, 1 and 5 on the left. Now middle value 5 that we have decided, we are going to generate a copy of 5 and send it to parent. Now here in B plus tree, you may find same numbers, but those numbers are different. One of those number is a key, is an index, whereas other one is the actual data. Okay, so here 5 is index, whereas here 5 is the data. That's the difference, remember. So B plus trees are majorly used for indexing. अपनी हार्ड डिस्क या जो भी है आप डेटा स्टोर करते हो, तो उसके अंदर जब आप इंडेक्स क्रिएट करते हो, देन it is actually creating B plus tree there. Now once you split your node and your leaf node is there, then don't forget to have a link in a linked list manner like this one. So these two are connected, leaf nodes are connected in a linked list manner. Don't forget that. So that we can say, ठीक है, नोड तो पेज जो है, डेटा पेज जो है वो स्प्लिट हो गया, लेकिन हमारा डेटा जो है अभी भी कंटिन्यूअस मैनर में है. इफ आई स्टार्ट विथ 1, तो 1, 5, 5 के बाद डायरेक्टली 8 का एड्रेस मुझे यहीं से मिल जाएगा, मुझे ट्री ट्रावर्स करने की जरूरत नहीं है. फाइन, 8, 8 देन 10, 10 के बाद अगर कोई वैल्यू होती तो मुझे वहीं से उसका एड्रेस मिल जाता. So that's how B plus tree works. Now still, let's say if we want to insert few more values on this one, let's say now we want to insert let's say we want to insert 4, we want to insert 12, we want to insert 15. So if I insert these three values on the same time, I'll not have any problem. 5. On the left of 5, we can have 1, 4, and 5 as a data. And on the right side, we'll be having 8, 10, 12. Till that point, we don't have any problem. But when I go and insert this 15, then we'll be having a problem. 8, 10, 12, and 15 cannot have 4 values in the same node. So we are going to split this one. 10 will become a new index value, and that will be copied and propagated to the parent node. So the final result will be something like 1, 4, and 5 you already have. Then 8 and 10 will be in the left node. 12 and 15 will be on the right node. Leaf nodes are connected with each other. And your parent node was having 5 already, and new index 10 will be stored there. And this will be your result. Okay, so that's how B plus tree insert operation works. Other than that, everything is similar to B tree. So any question or query here in B plus tree insert operation? Any question or query? Okay then. So we have seen B plus insert operation. Now let's have a look at B plus delete operation. Now when we are going to delete a data from B plus tree, as internal nodes are having index values, none of the internal node will have your data. Correct? एक भी internal node में आपको data नहीं मिलेगा. And we are not handling index actually. Index तो automatically handle हो जाएगा. That means B plus tree के अंदर जब आप data delete करने जाते हो, then your data will always be in a leaf node. Bottom level पे ही रहेगा. तो फिर यहाँ पे वो internal वाला केस नहीं देखने मिलेगा. अगर internal node से delete करते हो तो in order successor या in order predecessor लेके आओ, वो केस यहाँ पे नहीं होने वाला. Your data will always be in a leaf node, and when you go and delete your data, you are deleting a value from a leaf node always. So fine, first you need to search your data. Once you found it, that will be the leaf page. अब वो leaf page में से एक data delete करने के बाद you check your minimum constraint. If that leaf page underflows, अगर minimum value से कम हो जाती है, right, then we have a problem. Otherwise we don't have any problem. We simply delete that value. So if deleting a value from a leaf page and a leaf page underflows, then similar like B tree, we bring a data from sibling. Sibling के पास से हम data लेके आएंगे. अब data अगर मैं borrow करता हूं तो B tree में via parent node आता था. अब यहाँ पे भी वाया पेरेंट नोड आएगा, लेकिन डेटा डायरेक्ट आ जाएगा और करस्पॉन्डिंग इंडेक्स वैल्यू पेरेंट नोड में अपडेट होगी. ओके, करस्पॉन्डिंग इंडेक्स वैल्यू विल बी अपडेटेड इन द पेरेंट नोड. एंड नाउ इफ नन ऑफ द सिबलिंग हैव इनफ डेटा, तो फिर आप कोई भी एक सिबलिंग के साथ उसको मर्ज कर दो और करस्पॉन्डिंग इंडेक्स जो है उसको रिमूव कर दो, बिकॉज अब उसकी जरूरत नहीं. मिडिल इंडेक्स वैल्यू विल बी रिमूव्ड. जब दो नोड आप यहाँ पे मर्ज करते हो तो बीच की इंडेक्स वैल्यू जो है उसकी जरूरत नहीं रहेगी और वो सिंपली रिमूव हो जाएगी. Fine. So that's the b plus tree delete operation. So if we look at the delete operation example here, then let us start with one b plus tree already. So let me have, it's a 4-way b tree, so maximum I can have 3 values. I can have index 12. So I can always say that 5, 9, and 10 is less than 12. So it can be there. And the third node, let's say we have here, is any value, let's say 20 and 25. Right? Now, what is the minimum constraint here? 2 pointers, 1 value. अगर उससे कम हो जाता है, then we have a problem. So let's say I go and delete 9. So my result will be something like this one. Will not have any problem. We can simply delete that thing. Okay, we can simply delete 9. No problem. Now let's say next operation I want to perform is delete, let's say 10. Well, when I delete 10, there will be only one value 5, but still minimum constraint is being followed, so we don't have any problem here. So if you have lower order 4, okay? If you have degree of a node m, which is lower number, then it will not benefit you much. Okay, अगर ये order आप छोटा रखते हो तो आपको कोई ज़्यादा benefit नहीं होता है, because you can have single value in a node. Now why we have taken m-way tree? Because we want to have multiple values in a node. So here you don't have any problem. And when you delete this, even when you delete this 5, let's say delete 5, तो 5 delete हो गया, पूरा node ही निकल गया, then you can have these two nodes, and you can have correspondingly only one key. Whatever you want to keep it, you can keep it, and corresponding एक index जो है वो delete हो जाएगी, या तो 3 या तो 12. Index delete हो गया, and we have one index only. So this can happen. So when you have lower order, then there is not much benefit of going for m-way. Now, generally m-way trees are generated with somewhat higher order 5, 6, 7, 8 or so. Okay, so if you have five-way b tree, b plus tree, let me have 5 here. If we have 5-way b tree, then it will be something like, this is my data, this is my index node, and here let's say we have these values. So this is 5-way b plus tree, we can say, no problem. And now let's say we want to delete 10 here. Now there is 6 and 10. If I delete this 10, then I'll be having only one value in this node, and that violates the minimum constraint, right? A minimum constraint agar violate hota hai, then we need to bring one data from either left sibling or right sibling. पहले left के पास जाएंगे. Now left sibling is having 1, 2, 3 and 4, and it has enough data, so we can bring this largest value here. अगर मैं 4 को इस साइड में लाता हूं, then index में जो 4 है उसको चेंज करना पड़ेगा, so that will be updated. अब 4 की जगह आप लेफ्ट साइड से कोई भी एक वैल्यू को इंडेक्स बना सकते हो. So your final result will be, on a left side you will have 1, 2, 3. You bring 4 here, so you will have 4 and 6. 15 and 18 will be as it is. So still your data is in a continuous manner, but your index will be updated. 13 will be as it is, but here we will update our index value. Instead of 4, we'll update it with 3. So that's one example where we can borrow a value from left or right sibling. अगर आप 15 बोरो करते थे, मान लो कि वहां पे इनफ वैल्यूज हैं और आपने 15 को बोरो किया, तो 18 will become your index here. Right? Sorry, 15 itself will become your index here, because equal values we are going to keep on the left side. Okay, so अगर right side से borrow करते हो, then same thing will become index. अगर left side से borrow करते हो, then left value will become index. Now, so that was the example of borrowing a value. Now let's have a look at the example of merging a node. So next operation, let's say we want to perform is delete 15 itself. Now if I delete this 15, then there will be one value only, 18. Not enough value, so we bring or we borrow a value from the left sibling. Left sibling already have a minimum value, so वहाँ से कोई value ले नहीं पाएंगे. We go to right side and right sibling तो है ही नहीं यहाँ पे. So none of the siblings are having enough values here. Then what we do is we will merge. Okay, we will merge these two nodes. Now when you merge it, so 1, 2, 3 as it is रहेगा, and you are merging 4, 6, oh sorry, deleting 15, and we will merge these two nodes. So 4, 6 and 18 you are going to merge. Now when you merge those two nodes, then corresponding index 13 is not needed. अगर ये दोनों एक हो गए तो फिर उसको इंडेक्स की कोई ज़रूरत नहीं, and our index node will have only one key, 3. So at that point of time you are going to reduce your index. जब कोई डेटा नोड मर्ज होगा तो आपकी इंडेक्स जो है is going to reduce. So that's the delete operation on B plus tree. Any doubt or question here? Look, these AVL, B and B plus trees are important topics and it needs more and more practice. Okay, so I suggest that you do more and more practice here in these topics. It requires more practice. Okay, so that was B plus tree. Today we have started with B tree, insert and delete operation. Then we have seen B plus tree, insert and delete operation. We have also seen the difference between B and B plus tree. There are two major differences. B tree can have data anywhere at internal node, leaf node. But B plus tree will only contain your data at a leaf node. All the internal nodes will have the indexes. So key. That was first change. And the second change, all the leaf nodes are connected in a linked list manner. So that's the second change. And that was the B plus tree. Now, there is a special tree. Now, this is not that much special. It has been given a special name only. 2-3 tree. Okay. It is nothing but a B tree. It is nothing but a B tree. Let us see how. If interior nodes in your B tree is having either 2 or 3 children, okay, which means nodes with 2 children are called 2 nodes, and having 3 children are called 3 nodes. And this is just a different name provided. Now, if you do have 2 children, then obviously you can store 1 data only. And if you have 3 children, 3 pointers, then in between those 3 pointers, you can have 2 data. Okay. So this is nothing but a B tree with order 3, actually. 3-way B tree. 3-way B tree is nothing but 2-3 tree. Now, why it is? So when your M is 3, then you will calculate your pointers and values. Right? Maximum 3 pointers and 2 values. So we have that case here. Right? 2 data and 3 children. But when you go for minimum, then you take a ceiling of M by 2, which is what? 3 by 2, 1.5 is 2. So minimum 2 pointers and 1 value, and that's this case. Right? So 3-way B tree is something where we can easily understand, okay, a node can have either 1 value or 2 value at max. So correspondingly, it can have either 2 children or 3 children at max. And that's why it has been given a special name, 2-3 tree. Other than that, it's a simple B tree. So अगर 2-3 tree में आपको insert delete करना है, then it will be similar like a B tree operation. But it has, because of limited M value, it has some properties. A non-leaf node, whether it is 2 node or 3 node, okay, a 2 node will contain 1 data and has 2 children, and 3 node will have 2 data and 3 children. That's what we have discussed here in this table. Okay, 1 data, 2 children, 2 data, 3 children. And that's what you can directly define. There is not a range from minimum to maximum. You have only 2 options, either this or this, right? Then again, all leaves are at the same level. Definitely, if it is a B tree, then all the leaves will be at the same level. Data are kept in a sorted order because it is a search tree. And a leaf node will contain 1 or 2 fields. Fields is nothing but a data where you can store your data, right? So that's what the 2-3 tree properties we can discuss here. Now, I'm not going through this 2-3 tree insert and delete examples here. That will be homework or exercise for you. It's a 3-way B tree, so you practice it. In the next lecture when we meet, if you have any doubt or any question, we will discuss. Okay? So that's where we will stop. Now, till now, what we have gone through is we have seen AVL tree, B tree, B plus tree, and 2-3 tree. All these were the height balanced trees. These were the examples of height balanced trees. Next thing we want to look is the weight balanced tree, and that we will see in a next lecture after Diwali. Okay, so we'll stop here.